Hi everyone, today we are going to discuss thermal properties of matter. Before going into the topic, let us know what actually thermal properties of matter. To understand what actually thermal properties of matter is, let us consider a cube and this is a matter for us now. If we say physical properties of this cube, we say what is the height of this cube and what is the width of this cube and what is the shape. That is, we are saying it is in cubical shape. These are the physical properties of this block. Now, when we say thermal properties, that is when this block is subjected to heat. If we are heating this block, what will be the effects on this block? How it behaves in high temperature and how it behaves in low temperature. What is the thermal conductivity of this block? What happens if we use this one in refrigerator, and what happens if we use this block to make pans? Because when we are using this cubical block in a refrigerator, it has to withstand very low temperatures. If this block is used in pans, this block has to withstand very high temperatures. To understand the behavior of matter at various temperatures, we have to know the thermal properties of this matter. Hope that is clear. Now moving further, let us know what is the difference between heat and temperature. For that, let us consider the same block. When this block is subjected to certain temperature, this block becomes hot. But I cannot say how much hot it is. If I touch it, I can feel it that it is very hot, but I cannot say how much hot it is. Now the term comes, that is temperature. Temperature stands for the degree of measurement of hotness or coldness of any particular object or matter. For that, we have several devices already designed. We call them thermometers. For different applications, we have different type of thermometers. If we want to measure the temperature of human body, there is a different type of thermometer, that is the regular one, the thermometer used by the physicians, that is doctors. We have thermal scanners, which is also known as thermal gun. These devices are used to capture the temperature of objects from distance. You might have seen during this COVID-19, they are using thermal guns to know the temperature of human body. So temperature stands for the degree of measurement of coldness or hotness of any object. Now coming to differences between heat and temperature. Heat is a form of energy. Temperature is degree of measurement of hotness or coldness. Heat is a cause and temperature is effect. Heat flows from high temperature to low temperature. Temperature defines the direction of flow. Heat is measured in calories or joules. Temperature is measured in Kelvin or Celsius. Now moving further, let us discuss ideal gas equation. Before we discuss ideal gas equation, we should know what is ideal gas. Ideal gas is a gas which obeys Boyle's law and Charles' law at all given temperatures and pressures is known as ideal gas. The equation for ideal gas is PV is equals to mRT. To understand what actually ideal gas equation is, let us consider a piston cylinder arrangement. Let some ideal gas of mass m is present in this piston cylinder arrangement. Let volume of this cylinder is equals to V and temperature be T. When I apply load on the piston of this piston cylinder arrangement, this piston starts moving downwards. When the piston is moving downwards, the gas in the cylinder compressed. Compression means there is a decrease in the space occupied by the gas in the cylinder. It means that when pressure is increased, volume is decreased. By this, we can say that at constant temperature, pressure is inversely proportional to volume, because when pressure is increased, volume is decreased. It means that pressure is inversely proportional to volume. Let us keep this aside. At constant temperature, pressure is inversely proportional to volume. This is known as Boyle's law. Now moving further, for same piston cylinder arrangement, if we consider at constant volume, now I am increasing the pressure of this piston cylinder by heating. When heat is supplied to this piston cylinder arrangement, piston starts moving upwards. But we are restricting the movement of this piston because we are considering at constant volume. So I am fixing this piston so it cannot move further. At this point, if the temperature is increased some more, the pressure in this piston cylinder arrangement is increased. By this, we can say that pressure is directly proportional to temperature at constant volume. This is known as Charles' law. Let's keep this aside. Now moving further, if I remove the locks and start heating, when temperature is increased, this piston starts moving. It means that when temperature is increasing, the volume is also increasing, which means that temperature is directly proportional to the volume. Let us consider this one also. If you look at these three values, we can form an equation using these. That is, pressure is proportional to T and inversely proportional to V. That is, pressure is directly proportional to temperature and inversely proportional to the volume. If I take this V to the left hand side, it becomes PV is proportional to temperature. To remove this proportional, we have to introduce a constant which is known as gas constant, let it be R. Now this equation becomes PV is equals to RT. If we consider 1 gram per mole of gas at STP, that is standard temperature and pressure, this equation will become PV is equals to capital RT, where R is known as universal gas constant. If we consider mass also, this equation will become PV is equals to MRT, which is known as ideal gas equation. Thank you for watching the video. Please subscribe and press the bell icon to get notified whenever a new video will be uploaded. Please share with your friends.